Hello, Dee, and everyone. I'm Angelo, and I will be answering two Edexcel GCSE Foundation Paper 3 papers today. Paper 3. Yeah, let's get to it. I hope to do more in the coming hours. Maybe today I'll do 6. I've already answered 8 on paper, and I just want to capture it on video as well. All right. Let's start in here. So, oh, I forgot to. Okay, so in here, make sure that you use your calculator in general. This is a paper 3. Use your calculator to check. Percent is out of 100%. So it'll be 35 out of 100. You put it in your calculator, and if you hit equal, it would simplify it for you. If it changes, then I mean, it needed to be simplified. If it didn't change, then that means that it was already simplified and you just write it as is. So that's it, 7 over 20. Next one, we are rounding to the nearest 100. 8 is in the thousands, 0 will be in the 100. You look to the right, that's a 6. So if the digit to the right of what you're rounding is 5 or more, then you add 1 to it. So it'll be 8 and then 1, and then everything to the right of the digit you're rounding will become 0. So 8100. If it was 4 or less, then you keep it as is. Write down a number that is less than -5. So more negative means smaller number. Less negative means bigger number. So that is that. Next. I'll try to go as fast as I can while also explaining. If you have any questions, just pop it in the comments. What fraction of the grid is shaded? So this is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3 in here. So it'll be 7 times 3, 21 total. Then 1, 2, 3, 4, 5, 6. So it'll be 6 out of 21. Again, calculator. 6 over 21. What would that be? 2 over 7. I didn't need to put that on the calculator myself, but I just want you to get into the groove of using the calculator for these functions. And what you practice is what you do. Do not fool yourself into thinking that, oh, even if I don't practice doing this now, it will magically suddenly happen in the exam. No. What you practice will be what you do. So practice. Write down the value of the number 9, digit 9, sorry. So after the decimal point, it goes tenths, hundredths, thousandths. So 9 would be tenths. So 9 tenths. You say the digit and then you say what it is. So 9 tenths. Right. Okay, next, this is a pictogram. So what I like doing in here is go to the key after reading the question. Okay, read the full question always. It's just because I already read this before. I've already done the paper. I'm just videoing it right now. So the whole thing is 12. So 12 divided by 2 is going to be 6. So I just put it in here. And then a quarter, which would mean like 12 divided by 4, you can do do this in the calculator. I'll give you 3. So I just put it in here under, just so I know, like when it comes up, and it will come up, you have a half and a quarter in here, then I wouldn't need to think. It's already there, okay? I already did the thinking. 24 banana cakes were sold by year 7. So banana is 24. So this is 24. Now, how does that work? You have 12 for each circle. So what you want to do, if you didn't know it already, is you divide 24 by 12 and then see how many whole circles we need to put in there. It is 2 holes. If there were any remaining ones, then you would have to see if do you have to put an extra half circle, extra quarter circle. It depends. But in here it's just 2 holes. So They drew it with the sectors, like quarter lines in there, if you want. So I would draw it with the lines there as well. At the fair, year eight sold a total. These are year sevens. Be careful. Year eights sold a total of 150. Which year sold the most cakes? So this is going to be a comparison. So these are year sevens and these are year eight. So we just need to figure out how many of these we have. So what I'd like to do as well is to just put the numbers beside this. Of course, you can't move stuff on the paper, but just erase it, I guess, or just like okay. So what I like doing as well is if you write something, right, just do one line, just to remove it. If you're using a pen, it's just so messy if you just do that. It's just unsightly. I feel so. For here, each circle, I write what it is there. So that's 12, that's 12, that's 12. And then a quarter, again, in here is 3. So you got 12, and then you got 6, 12, and then 12. I mean, we already did that. This is 24. So in here, 12 times 5, again, you can put in the calculator, is 60. 12 times 3 is 36, plus 3, 39. 12 plus 6 would be 18. And then you're going to add all of that. So you got 60 plus 39 plus 18 plus 24 is 141. This is for year sevens. And then we can see that 150, which is year 8, is greater than 141, which is year 7. So which year sold the most cakes at the fair? It will be the year 8. So you put it on the underline here. It's just I. Yeah, there at the line there. So yeah, that is that. Easy, right? Easy. There's another way you can do this, like a quick counting method. So you count the holes. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 times 12, 9 holes, right? And this is 6, and this is 3. So together that'll be 9. No, 9 times 12 was 108. Wait, is it? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh yeah, sorry. Wait. I erased the 2 in here. Oops. Sorry. So there were 2 in here, right? Because of the 24 banana cakes. So 3, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11. Yep, 11. But times 12. I'm messing up. So make sure you check your work. Make sure you check your work. Every circle is 12, and there's 11 circles. So 12 times 11 is 132. And then you have an extra 9 in here. So 132 plus 9 is 141. So that is quick. That is quick. Just be careful in counting. Right. Miklos is swimming lengths of a swimming pool. Each length is 25. So with these things, I always like to do just a quick sketch of what's happening. So one length, meaning like just one go, not forward and back, just one. 25 meters, that's one length. Miklos has swum 178 lengths, so 178 of this, so that means definitely 178 times 25. Put it in your calculator. It's 4,450 meters. And then he wants to swim a total distance of 8,050. How many more? Meaning you're going to subtract here. 8,050 take away 4,450 is going to be 3,600 meters. But is that the final answer? No. It says how many more lengths, not how many more meters. So each length, again, is 25 meters, right? So it'll be 3,600 meters divided by 25 to find out how many 25s are in there. And you would get 144. So 144 lengths. Make it a point as well to circle or like put a box on your final answer, just to make it easier for whoever's going to check your work to mark it, so they can see immediately where your final answer is. So this one, you can use a calculator for this. This is an arithmetic sequence, meaning it's either adding or subtracting the same thing every time. So you would pick one term that's like to the right of some term. So let's say 91. And then you take away the previous term, 97, and then it would tell you what the difference is. It's a -6, meaning it went down by 6. So again, if you already knew that mentally, then you didn't need to. But if you wanted to use the calculator, then that's it. If you want to, you can also check just in case. 91 minus 6, does it actually give you 85? It does. So that means that it's confirmed you are taking away 6 every time. So in here, take away, explain how to work out the next number, take away 6. Or subtract 6. Work out the difference between the 5th and the 7th term of the sequence. So it's not really hard, but just need to understand this. To get to the 6th from the 5th, you take away 6, right? To get to the 6th to the 7th, you take away 6. How do you go from 5th to 7th? Then you take away 6 twice, meaning 6 plus 6, 12. You took away 12. So that is the difference then. The 7th term is 12 away from the 5th term. Explain why 52 is not a number in the sequence. So I'll start with the method that I suppose is more intuitive and less algebra. Okay, coffee first. Pause it and get your coffee as well. So you got the first term is 97, right? And every after that, you're just taking away 6. It's just a matter of how many 6s are you taking away. But it's always 6s that you're taking away. So what we're going to do is this. 52, and then we take away 97 to find out the difference between them. 52 minus 97 would give you -45. So it's 45 away. Now, again, you're taking away 6 every time. So that means that the difference, if a term is actually in the sequence, has to be a multiple of 6. Okay? So is 45 a multiple of 6? No. You can test it in the calculator. Like if you go 45 divided by 6, if you get a decimal answer, like not a whole number, that means that there is a remainder, so it doesn't go in. So you can say 52 is not in the sequence because the difference from, I actually write better than this. I'm just excuses. I'm just hurrying. Difference from the first term is not a multiple of 6. So that's fine. That's done. I mean, it is just 1 mark, so I mean, it's not that much of an issue. But another way to do it is this. So you find the nth term formula first. Again, the nth term formula is basically a formula that you'll be using to find any term in the sequence where you're using n. N is just a number that represents the position the term has in the sequence. So if n was 1, then you're looking for the first term. If n was 3, then you're looking for the third term, and so on. So that's why they call it the nth term. Whatever n is, that you can find it using the formula. So finding the nth term, so we will have to be using the difference, the common difference we say, which is the -6. So what you're going to do is this. You start with the -6 and then you multiply it with n, okay? And then you're going to try plugging in some n value. Normally we just plug in the first one, so n equals 1, right there. And then you're either going to add or subtract something to that to make it correct. Now, the first term is 97, right? So -6 times 1, that's going to be -6. And then you're going to have to add something in there to make it 97. What is that? So -6 plus 6 would get you up to 0, right? And then, so we already added 6. And then from 0 to 97 is 97. So that means that you're going to have to add 6 and then 97 to -6 to get to 97. So it's 103. So that's it. That's -6n and then plus 103. This is the nth term formula for this sequence. Normally we do, I do a quick test. Does it actually work? Let's test it for the third term. So -6 and then n would be 3 for the third term and then add 103. -6 times 3 is -18 plus 103, or basically 103 minus 18. What do you get? You get 85. So you do actually get the third term using the nth term formula. So it does work. Okay. Now, how would you prove that 52 is not a number in the sequence? You're going to now equate -6n plus 103 to 52, because if it is in the sequence, then you would find the n value that would give you that. And the n value is always a whole number. It doesn't make sense to have a 3.5 term or a 4.2 term. Doesn't make sense. So it's always a whole number. So you take away 103, take away 103, and then -6n is alone now. 52 minus 103, use your calculator. This is -51. And then you divide by -6, divide by -6. It's already looking bad, right? It is going to become a positive, though, which is good and cannot be negative. The answer is 8.5. So again, it doesn't make sense that a term is the 8.5 term. So that means that, so since, you would say in here, since n is not a whole number, then 52 is not in the sequence. Now, it does tell you something, though, not for this specific question, but the fact that n is 8.5 means that 52 is in between the 8th and the 9th term. Now, that's not useful in this question, but just maybe in some other question. Keep that in mind. Next, Mandy buys 12 kilogram bag. Oh yeah, by the way, as I'm reading it, I normally just do that, like mark the important stuff and then keep it in my mind as well. 12 kilogram bag of dog food. Mandy's dog, so just one dog, has 3 meals a day. She gives her dog 105 grams of dog food for each of the meals. Okay, I'm already formulating a plan in my head. How many complete weeks, so we're looking for weeks here, will the bag of dog food last? You must show all your working. Always show you're working anyway, but yeah, more so in here. So, right, we have 12 kilograms of dog food, and then we need 105 grams. Immediately, this is so important. Immediately, you should notice that it is a different unit. Different unit. So, you need to make it the same. It's easier to go from a big to a smaller unit because it's just going to be multiplying. So one thing, 1 kilogram is 1,000 grams. One thing that I say to D as well, and some of my other students, is if you see a kilo, it means 1,000. If it's used as a prefix or puts in front of a word like kilometer, 1 kilometer is 1,000 meters. 1 kilogram is 1,000 grams. So keep that in mind. For some reason, the prefixes are not really taught properly nowadays. So at least kilo, remember that. Like back in my day, there's like we know centi means this, kilo, hecto, deca. But anyway, kilo, that's good for you. That's good enough for this. So 12 kilogram is how many grams? Every 1 kilogram is 1,000 grams. So 12 times 1,000 would be 12,000. And then I will put the unit there just to remind me. So this is what you have. So we have 12,000 grams available. So I'm labeling this for whoever's checking it to follow my working out, but also for me to follow my working out as I'm doing it for the first time and also as I'm checking it. Okay. 12,000 grams available. Now, Mandy's dog needs to get 3 meals a day, 105 per meal. So it'll be 105 3 times a day. So 105 times 3 would be 315 grams per day. This is just a day. And then we're looking for complete weeks. So we need to find out how much this dog eats in a week. So 7 days in a week. So 315 times 7 is 2,205 grams. I'm not doing this mentally. I already have my my stuff here. But use your calculator in this. So per week. And then we have 12,000 grams available, right? So how many 2,205s can you fit into there, right? So let me divide. So divided by 2,205, and that would be around 5.4. Around 5.4. And that is the 2,205 is the amount per week. So that means that this is around 5.4 weeks. But always check what form do they want the final answer to be. And in this case, they want it in weeks. So in here, if they want it in weeks, then in complete weeks as well. So the 0.4 of a week, that's not a complete week, just part of a week. So we go 5 weeks. This is the final answer. You put it on the line, 5 weeks right there. That's the final answer there. Okay, so put it on the line. Next, polygon names. So let's just go over the naming quickly. And it depends on the number of sides that it has. Let's go with... Oh, wait. I think I wrote something on top, but you can't see it. I forgot. Anyway, that I was describing kilogram as well anyway. Okay, I forgot that I cropped it that far out. All right. So good thing I noticed it now. So let's say 3 sides, 4 sides, 5, 6, 7, 8, 9, 10, 11. Let's go to 12 only. So these are the names of the polygons for these number of sides, n, let's say. So if it has 3 sides, you know this is a triangle. 4 sides, in general, it's a quadrilateral. So not square, not rectangle, quadrilateral. Quadri or quad, that means 4. Lateral means side, so 4 sides, quadrilateral. 5 is pentagon. 6 is hexagon. What I think is like, it sounds like 6, right? 6, hex, 6, sixagon, hexagon. 7, there's 2 ones that we use. It's either heptagon, mostly, but sometimes called septagon. 8 for octagon, like octopus. 9 for nonagon, basically sounds like 9. 10 for decagon, as in like decathlon. Here. And then 11 is undecagon. And then 12 is dodecagon. Normally after that, we don't really name it. I mean, there are names for it, but we're not expected to know them. After that, normally what we just do is go like 13 gon, meaning 13-sided polygon, or like 20 gon, something like that. Anyway, so in here, there's 1, 2, 3, 4, 5. So that'll be a pentagon right there. Sometimes you would be also asked something about regular polygons. Regular polygons, let's say that one, regular pentagon, say. Regular means all the sides are the same length, and that also means that the angles inside are also the same. Just keep that in mind. This is a prism. How we name prisms is by what the cross section is. The cross section in here is this pentagon. I suppose the easy way to spot it would be like if it's like the same face, one after the other. Like you have this face, let's say this face is a pentagon, and then the other face, like the other side, the opposite side is also a pentagon, then that means that that is the cross section of the prism. So this is the exact same prism. So it is what's called a pentagonal prism. And here it says that each edge of the prism has a length of 7.5. So this is 7.5, 7.5, 7.5, everywhere. 7.5. Work out the total length of the edges of the prism. So this is what I do. Easy to count. So you go, you don't need to redraw it, but so you have 5 here, right? So that's 5 edges. And you have another 5 edges on the other pentagon. And then how many lines would you need to connect the corners of this pentagon with the other pentagon? There's 5 vertices for 5 corners. So that means that you need 5 lines as well. So you go 1, 2, 3, 4, 5. So 5 here, 5 the other side, and 5 in the middle. So it'll be 15 edges. And each edge is 7.5. So 7.5 times 15. They gave cm, and the answer is in cm. So just make sure you're keeping that in mind, because sometimes they would try to slip one past you. 7.5 times 1.5. No, 15. Oops. 112.5. Use your calculator there. There are only red counters, blue counters, and green counters. So in here, say red, blue, green. I like to put it on top just so that I know I don't need to look at the other stuff. This is just for speed. What fraction of the counters in the bag are green counters? So what fraction of the total they mean? So we need to add that 2 plus 16 plus 7 is 25 parts total. Now, how many parts for the green? It's 7. And it's 7 out of 25. There. If you put in the calculator, you would see that you cannot simplify it further. So that is that. The chess match lasted 3¼ hours. The match finished at 2:10 p.m. or 14:10. What time did the chess match start? Be very careful here. Finished at 14:10. How much? What time did it start? So we're gonna go back. Okay, careful here. I can already see people getting a mistake on here just because they see 3/4 hour, 14:10, straight to adding. No, please don't do that. A quarter hour. So an hour is 60 minutes. And what is a quarter of that? So you go 1/4 of 60. If you want 1/4 times 60 is what the off means in math, basically, in these questions. And if you plug that whole thing in the calculator, you get 15 minutes. You can also do, like, if you want to do mental math, 60 divided by 4, which is 50, and then times 1. That's like the general way of doing it. So 3¼ hours means 3 hours and 15 minutes. So that was the time that has passed for the chess match. So you go 14:10, and then plus 3. Let's go plus 3 here. Plus 3. 3 hours. So, okay, that's a mistake. We're going back. Again, minus, okay? Minus 3. So 10 still. 14 minus 3 is 11. So 11:10. And then we're going to have to go back 15 minutes. The 15 minutes, we can split it into 10 and 5. Why did I split into 10 and 5? Because you have 10 in here. So if you take away 10 minutes here, then it will be 11. And then now if you take away the remaining, so we're done with the 10, take away the remaining 5 minutes, then it will be 10:55. Maybe I shouldn't be writing it like this, because that might confuse you, but just keep in mind that 1 hour is not 100. So you don't like borrow from here and then make it 100. Okay, don't do that. 60 minutes in an hour. So 60 minus 5 is 55. Another way I did it before when I was studying is, if I want to do it this way, I would, because it's 11 hours, I would make it so that it's 10 hours, and then I give the 1 hour into the minute. So that'll be 60 minutes. Then I subtract this so that you can do it. So 10 minus 0 is 10, and then 60 minus 5 is 55, if you want. Simplify this. So always make sure that the variables are the same, exact same, including the exponent or the indices. It has to be the same. So in here, 8 plus 14 is 22, minus 2 is 20, and then just copy the variable h cubed. You can put it in the calculator as well, 8 plus 14 minus 2. And then all of this, I like, so it's in brackets, divided by 3. I like writing it like this. More straightforward, I suppose. Both of them have y, so you just add, it's in brackets. You do that first before dividing. 9 plus 12 is 21y. Yeah. And then 21y divided by 3 is 7y. There. I think that's, yeah. So in here, if you are doing this, what I like doing is just changing everything into decimals. Just makes it very easy. 7 over 12, what is that in decimal? It is 0.583 recurring. I just put it like that, and then you have 0.56. 57% to decimal, just move the decimal point 2 to the left, or if you want, divide it by 100, you get 0.57. And then 6/11 is going to be 0.5454 something. ... Okay, so let's start with this. This is a 5/8, so that's not the smallest. 5/6 maybe, 5/7 no, 5/4 okay, this one, and then 5/5. So it looks like this one first. Make sure though that you write the original number, not what the decimal that we use to arrange it, but the original. So 6/11. I just write 1 here. And then after 5/4, we go 5/5, I think. So 0.558. And then after 5/5, we go 5/6. 0.56, and then 57, so no, 57%, and then 58, so which is 7/12. Easy, done. Giveaway points. Free 2 marks. Okay, let's zoom out a little bit. A travel agent sold 100 holidays in April, so that's just the total. Each of these holidays was in the UK or abroad. 64 out of the 100 holidays were sold to families. So families on here, so 64. And then 100 minus 64 would be 36. So that would be the rest. What I do is I like checking the information after I've used it, so I wouldn't need to look at it again. The rest of the holidays were sold to couples, so we already did that. We got 36. 11 out of the 18 holidays abroad. Okay, abroad. So we look here and here. 11 of the 18, so meaning like 18 total for both of them. 11 of the 18 were sold to couples. So couples is here. So it would be 11. And then 18 minus 11 is 7. So that's going to be the rest. So we have used all the available information in here. Check. We know that both of these would be 64. So 64 minus 7 is 57. So that's 57. And then both of these would be 36. So 36 minus 11 would be 25. So 25 in there. Okay, complete. Next, one of the holidays sold to a family is chosen at random. So this is, be careful here, be careful. One of the holidays sold to a family. Okay, specifically family. How many families were given the holidays? 64 families. So it will not be out of 100, which is the total of everyone. Every holiday that was sold is only out of 64 because they said the holidays would be one of the holidays sold to a family is chosen at random. Find the probability that this holiday was not abroad, so meaning UK. So we're going to take from 64 and not abroad will be this. So it'll be 57 out of 64. So you would put that in the I don't know why I squeezed that in. All right. So there, 57 out of 64. You can put it in the calculator. You should always put it in the calculator to check if it's already simplified, and it is. Okay, so here, 8 over x over 7 plus 9 equals 4. So the x is with x over 7, so that needs to be alone first. So we go minus 9, minus 9. This goes away. 4 minus 9 is negative 5. Use your calculator if you can't do that. Times 7 here, because the opposite of divide is times. This cancels out. X is equal to negative 5 times 7 would be negative 35. Right. Question 17. Blake works 32 hours a week in UK. Let's just highlight that. She is paid this much per week. Blake applies for a job. So this is UK. Applies for a job in Australia, and the rate of pay is $26.40 per hour. This is the conversion. Blake thinks the rate of pay is greater than the rate of pay in the UK. So in here, this is per week. This is per hour. So let's just make it per hour for the UK pay. So 32 hours a week. And this is the pay a week for 73.28 pounds. So what do? We go 473.28 pounds. And then we divide by 32 hours. and we get 14.79 pounds per hour. This is UK pay. And the thing is, the Australian job is in Australian dollars per hour, of course, and this is in pounds. So we need to convert it first. So 1 pound is equal to 1.796 AUD, Australian dollars. And you want to convert 14.79 pounds to AUD. So let's look at it as a ratio, which it is. 1 times what to get to 14.79? It would be times 14.79 and then times 14.79 as well. And that would be 25.56 AUD per hour. Again, this is UK. So we can compare now. We can see that 25.56 AUD is 25.56 AUD is less. Oh, please don't do that to me, pen. 25.56 AUD is less than 26.40 AUD. And the 25.56 AUD is for the UK pay, and 26.40 is for the Australia pay. So if we just look at the payment, it looks like Australia is better. What was the question? Blake thinks the rate of pay in Australia is greater. And is it? Yes, it is greater. Is Blake correct? Maybe just do that. And then yes, Blake is correct. That's good enough. So because we have shown that it is actually greater. 3 marks for that. Okay. Here is a shape made from a rectangle and a triangle. The shape has exactly 1 line of symmetry. What is line of symmetry? It's a line where if you fold a shape over that straight line, the left side and the right side will basically overlap, and nothing will be sticking out. It's exactly the same. In here, why did they say that it has exactly 1 line of symmetry? Let's read on. I'll explain later. The area of the rectangle, so let's write that down. Area of the rectangle is equal to 3.5 times the area of the triangle. Okay, so check. The width of the rectangle is W centimeters, so that means that this is also W. Work out the value of W. So we're given the total area, so that probably means that we need to find the area of the rectangle and the area of the triangle. Area of the rectangle is just length times width, so 14 times W, that's it. I don't know, we were not given the total area, just the relationship. For triangle, we need base times height divided by 2. Now, this is the thing. We don't know what the base is. We know this is 3.8. We don't know what this is. Or do we? So they said that there is exactly 1 line of symmetry. That means that the line of symmetry is actually here. And if you fold it, it will be exactly the same. If it is in the middle, okay, if it is in the middle, wait a sec. Did it say it was isosceles? It didn't really. So I think it's safe to assume that it is one in here, because it's this is the line of symmetry. So if it's not isosceles, it wouldn't like go over properly. So it is isosceles. So that means that this must also be 3.8 centimeters symmetrical. And yeah, one thing unrelated to this, if it is isosceles or equilateral, if you drop down this height right there, that height is actually going to cut the base into 2 equal parts. And the base angles are the same. So remember that about isosceles. Anyway, so we need to find the base length for the height for the triangle. So the whole thing is 14, right? This whole thing is 14. If we do 3.8 plus 3.8, we get 7.6. And then 7.6 taken away from 14 would give you 6.4 cm. So this is going to be the base of the triangle. 6.4 cm. Now, I think I'll just take this, put it to the side a little bit. So the area of the triangle, again, is length times width. It's just 14 times W. So we'll replace this with this. That's the area of the rectangle. Then 3.5 times the area of the triangle. Now we know. Base times height divided by 2. Base is 6.4 times height is 6 divided by 2, right? So what is that? 6.4 times 6 divided by 2 is 19.2. And then you got a 3.5 in there. Now, how do we find just the width? We divide by 14 because it's multiplying 14 to W. And then the width would be 67.2 divided by 14. And then width is equal to 4.8 centimeters exactly. That's it. That's the final answer. Put it on the line. Again, make sure that you write down the answer how they want it. Always looking for, oh, do they want it in one decimal place? Do they want it like however many significant figures? So yeah. Anyway, they were looking for W, and that was it, 4.8. Next, the front elevation of a cuboid is shown on the centimeter grid below. So that means that each of these squares have 1 centimeter length. The volume of the cuboid is 224 cubic centimeters. Okay, so this is a front elevation. So that's what it would look like if you look at it straight front. So let's do a quick drawing of that. So this would be the front, the thing that you're seeing right now. That'll be the front of the cuboid. Now, let's try and draw the rest of the cuboid. So something like that. The volume of a cuboid is length times width times height. Right? Now, it looks like here, 1, 2, 3, 4, 5, 6, 7, 8. This is 8 cm. And then the height would be 1, 2, 3, 4. So this is 4 cm right here. And we're looking for the plan of the cuboid. So plan is when you're looking at it straight down. As if you're looking at a plan or something. And you're looking at it straight down, like bird's eye view. So that means that it's only this that you would be able to see. That means that we need to know the measure of this, which is 8, it's the same, and the measure of that, which we don't know right now. So the volume, you'd find that by doing 8 times 4 times whatever this is, say x, length times width times height, times x. Now the volume, the total volume, we know what it is. It's 224 cubic centimeters. All of our other measures are in centimeters, so it matches up. Don't need to convert anything. 8 times 4 is 32. Times x is 32x. How do you find just x? You divide by 32, divide by 32. This cancels out. So x is equal to 224 divided by 32, 7. So that means that this is 7 cm right there. So when we look down, we're going to see 8 and 7. So this is the 8. So that needs to be like the same in the same line as this. So and then 7, right? So from here, 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7, 8. So there, that will be it. That'll be the plan view right there. I also like to label it. Don't necessarily have to do that, but so this is 8 cm and this is 7 cm. Standard form. So in here, you want, for the standard form, you want the number in front, the coefficient, to be between 1 and 10. So the decimal point needs to be right there, 4.68. That is less than 10. And how many steps would you take for 4.68 to go back to the original form? So you go 1, 2, 3, 4, 5, right there. So that means that will be 4.68 times 10 to the 5th. Now, -4 means that you're going to move the decimal point 4 to the left. So you go 1 to clear the 5, and then 3 with no digits there, meaning 3 zeros in between 5 and the decimal point. Normally, if there's nothing to the left of the decimal point, we put a 0. So the final answer would be 0.0005037. By the way, standard form is that. Ordinary form is that, like with no power of 10 thing. Okay. Here is a bias spinner. The table shows the probabilities that when the spinner is spun, it will land on A, B, C, D. It is biased because the probability of each of them coming up is not the same. Luca will spin the spinner 200 times, work out an estimate for the number of times it would land on A. So this is the technique every time. This will probably come up. So you're going to take the probability of whatever it is they want, 0.4 for A, and then you multiply it by 200. The number of times they try the thing. In this case, it's a spinner. So 200 times 0.4 will be 80. So that means that on average, we're estimating that A would come up 80 times if the spinner is spun 200 times. And the probability for A is 0.4. We're at number 22. Seija works at a weather station. Table gives information about the temperature T in Celsius at midday for each of the 50 cities. So Celsius, 50 cities. Calculate an estimate for the mean temperature. So in here, this is a grouped frequency table. So we got 10 to 15, 2 cities. So we don't really know exactly how many degrees Celsius each of those 2 cities had at this specific day. So what we're going to do is to go halfway in between 10 and 15. If you've done so many of these, then you just know. 10 and 15 are 5 away. So halfway would be 2.5, and then you just add 2.5. But if you must know, the calculator way of finding the middle would be just add them. So 10 plus 15 and then divided by 2. That will give you it 12.5. Then you just keep doing that for the other pairs. So it'll be 12.5 here, 17.5 here, 22.5, 27.5, and 32.5. So we're assuming that each of these 2 cities had 12.5 degrees Celsius, 8 cities had 17.5 degrees Celsius, and so on. So we're going to multiply all of them. 12.5 times 2 is 25. 17.5 times 8 is 140. 22.5 times 13 is 292.5. Next one is 577.5, and next one is 195. So if you add all of that, it's 1 to 30. This is the degree Celsius. And then if you add all the frequency, it will be 50, because they said it right there, it's 50 cities. And then, how do we find the mean? So you're going to divide that. 1,230 divided by the 50 cities would be 24.6 Celsius. So on average, in each of the cities, it's around 24.6 Celsius for them. So, I mean, for someone who came from a tropical country, 24 is kind of cold. Seja says the median temperature is 22.5 because 22.5 is the middle number in the middle group. Is Seja correct? Seja, I don't know if that's a girl name or a boy name. So let's say boy name. So what he's saying is that 22.5 will be the median because that's in the middle group, and that's the middle of the middle group. So it doesn't work like that. It doesn't work like that. There's 50 cities, and you need to go in the middle of them, not here, but in the middle of the 50 cities to find the location of the median. There's a formula. It's a quick formula. It's n+1 divided by 2. N will be the total number of things that you have. In this case, it's 50. So 50 plus 1 divided by 2. And that is 25.5. So it's like the median is in the 25.5th position, which is halfway between the 25th and the 26th. So as you can see here, from 10 to 15, there's 2 terms. So the first and second term are right there. From 10 to 20, there will be 2 plus 8. It's up to the 10th term. Okay, up to the 10th. And then if you add 23, add 13 here. So the third group would have until the 23rd term. So that means that the 25.5th term is not right there. It's in the next group. Okay, so that means that Seja was wrong. This is where the median is. And also, you can actually find the median in here, but I don't think you're going to do that in Foundation. So we just say that 25T, like that thing, is the median class. Like the median is somewhere in there. I suppose you so you say Seja is wrong. And then I think that's a good enough explanation. We need to find the middle of the frequency. Middle of the frequency, not the middle class. That's a different middle class right there. Okay, there. Jenna is asked to show the inequality. This is called a compound inequality because it has 2 inequality symbols in one line. So if you have, you're going to read it like this as well. You're going to read from the middle left, middle right. So you would say x is greater than -3, but less than or equal to. There's an or equal to because there's a line under there. And here there's none. Equal to 4. So it will be, the values will be between -3 and 4, but cannot be -3 and can be 4. So the open dot refers to like the value going to there, but not including that. And if it was shaded, then it will be up to there and including that point. So in here, so we need to start at -3, which is here, not -2. So that was the first mistake. That was the first mistake right there. Two mistakes. The dot on the left needs to be on -3, not -2. Next one, this thing right here needs to be shaded because it's or equal to 4, so it can be 4. The dot or the circle on the right needs to be shaded because we have this and not this. Okay. I don't think I'm going to be able to do the 2 papers. I need to go in a little bit. Let's see. Add 7. 5y, 16 plus 7 is 23. And then divide by 5. Y will be less than 4.6. So, oops. Not reading the question. Work out the greatest integer that satisfies the inequality. Integers, what are integers? These are just the whole numbers, both positive and negative, including 0. These are integers. Now, y needs to be less than 4.6. So what is the largest whole that could be also less than 4.6? That would be 4. So 4 is less than 4.6. You can't go any higher than that for the wholes, and it also being less than 4.6. So that's that. Are we almost done? Ali buys a pack of balloons and box of pencils. There are 30 balloons in each pack, 24 pencils in each box. Ali buys the same number of balloons and pencils. Work out how many packs of balloons and how many pencils of boxes of pencils should he have bought. She could have bought. You must show all your working. Right. Ali buys exactly the same number of pencils. Okay. So these questions need to be like in your head. Oh, it's an LCM question, least common multiple. The straightforward way of doing it will be just writing down the multiples of 30 and multiples of 24. So like 30 times 1, 30. 30 times 2, 60. 30 times 3, 90, and so on. Basically the 3 times tables, but with a 0. And then you can also do that for the other one, 24. So 24, 48, 96, 120, I think. So, yeah. So you can see it's right there. 120 will be the least common multiple. So that what does that mean? That means that the 30 goes into 120. 24 goes into 120. So that means that Ali bought 120 balloons and bought 120 pencils as well. if we continue this, we would keep hitting a common multiple. The 240, like twice this, would also be a common multiple for these. This is the reason why work out how many packs of balloons and how many boxes of pencils she could have bought. So this kind of like, this is why it's a bit soft in the wording, because there's not just one answer in here. But let's do the lowest one because it's the easiest here. I like the Venn diagram method more. I'll just show you the Venn diagram. I think you know this. So you take the two numbers and do factor tree to find the prime factors. So for 30, we have 5 and 6. 5 is prime, circle. 6, 2 and 3 primes, and then 4 times 6 for 24. 4 is 2 and 2 prime. 6 is 2 and 3 primes. So it looks like they have 1, 2 in common, and then 1, 3 in common. Anything else? That's it. So they got 2 and 3 in common right here. Let's do the Venn diagrams. Venn diagram. So you got 2 and 3. So 2 and 3, which is this, and then 5. So we'll put 5 there. For 24, we got, let's say 2 and 3, so that, and then we have 2 and 2 left. So put it here. This is the highest common factor, 2 times 3, which is 6. But we need the LCM. So it'll be 5 times 2 times 3 times 2 times 2. I'll let you in on a secret. It's not really a secret, but what I do. If I have a 5 and 2 to a string of things that I need to multiply, I would do that last. So 5 times 2 is 10, making it very easy. 3 times 2 is 6. 6 times 2 is 12. 12 times 10 is 120. So there, we found the same answer. Just so happened that in the first method, that was just the fourth number that come up. But sometimes it comes up like way later in the list, in which case the Venn diagram will be faster. So I'd go with the Venn diagram every time. So for the balloons, they come up in 30 balloon packs. So how many packs of balloons? If it's 120 total balloons, we need to divide by 30 then, and we get 4. For the pencils, they come 24 pencils in a box. So if they bought 120 pencils, you divide 120 by 24, you get 5. So that's it then. 4 packs of balloons and 5 boxes of pencils. Probably. That would be the least number. A company orders a large number of plates from a factory. It would take 30 hours to make all the plates using 4 machines. How many machines are needed to make all the plates in 6 hours? Now, in here, I would teach you like a more mental math way, but since you are using a calculator anyway, I'll just teach you the short way. This right here, you need to think first, like, is this going to be a direct proportion, like as one increases, the other one increases, or is this inverse? So in this case, this is an inverse proportion, inverse proportion, because the more machines that you have to work on this thing, the less or the fewer hours you would need, right? So if you remove some machines, then you would need to, you need more hours to do the same work. So this is what we know. 30 hours is to 4 machines. Now, the main mistake in here is like going straight to like, 30 hours divided by 4, right? It doesn't work like that. How many machines are needed to make all the plates in 6 hours? So 6 hours right there. Now, 30, how do you go down to 6? You divide by 5, right? Now, since this is inverse proportion, whatever you do on one side, you do the exact opposite on the other side. So that's a shortcut. So if you divide by 5 here on the left side, you'd have to multiply by 5 on the other side. So 4 times 5 would be 20 machines. If you think about it this way, you want to finish the job in a fifth of the time, or like 5 times as fast. So that means that you would have to get 5 times more machines, which makes sense, right? So how many machines needed to make all the plates in 6 hours? 20 machines. You can just write 20 there. I just like writing what it is. 26. Riley traveled by car and by airplane. He traveled 143 miles by car. And so that's the distance. I like labeling it. Speed here. Riley then traveled 5 hours and 20 minutes by airplane. Work out in hours and minutes. Riley's total traveling time. I like also having students write this immediately in here. In here, we're looking for total traveling time. So it's this. To get that, you would do this. Distance divided by speed. So I'll just write it here. Time is equal to distance divided by speed. There's 2 parts, the car and the plane. So for the car travel, oh yeah, by the way, make sure that all the units match up. So the distance is miles, and then this is hours. So just make sure that it's all good. We do times equal to distance, 143 divided by the speed, which is 55. 143 divided by... Wait. Yeah, 143 divided by 55 is 2.6 hours. Okay. Now, Riley traveled for 5 hours and 20 minutes. They want the answer in hours and minutes. Here, can't see it there. I think I'll just move that. Okay. Now 0.6 of an hour. What is it? So that's in hours. An hour is 60 minutes. So it's, if you do 0.6 times 60, you get 36 minutes. So that means that 2.6 hours is the same as 2 full hours, and the 0.6 hours is 36 minutes. Now for the plane, it was 5 hours and 20 minutes. So that means that the total will be just both of them added. So you got 2 hours, 36 minutes, and then you got 5 hours and 20 minutes. And you just add that. 36 plus 20 would be 56 minutes. That's well within an hour. If it goes over 60, then you need to like take away the 60 minutes and then leave the rest, and then the 60 minutes you put into the hour column. But in here, it's not that easier. So 7 hours here. So 7 hours, 56 minutes. That'll be it. 27. 28. Okay, we're close. So 27 solid cube, pressure is equal to force times area. We have a given pressure, newtons per square centimeters. Newtons in here, so the force unit matches up. So we got pressure, we got force. We are looking for total surface area. This is show that question, so it kind of already gives us the answer. We just need to prove it. We're looking for area, total surface area. So how do you get area here? We can write it like that. PFA, like this. And if you're looking for the area, then it's the force divided by pressure. So area is equal to force divided by pressure. So, what's that again? Force is 504 newtons. Pressure is 3.5 newtons per square centimeter. So 504 divided by 3.5 is 144 square centimeters. And 144 square centimeters is definitely less than 900 square centimeters. Right there. Let's just show that it is less than. Next is finding the equation of a straight line. So the first thing that I would do in here, because y equals mx plus c for a straight line, right? The c being the y-intercept, include the sign in front. That's the y-intercept, or where the line goes through the y-axis. In this case, it's right there. So c is 3. So y equals mx plus 3. And then you're going to use that point and take a look at along the line which other point you can use. The points that you can use will be points that are on the intersections of the grid, because we're going to count the steps. That's okay. But points that are kind of like in the middle-ish, like that, not quite at the intersections, that's not okay. So in this case, the closest one that is okay to this, so that's not okay. This one is, so let's take that. I like going from left to right always. And the gradient is rise over run. Rise is either up or down. Run is either right or left. Up is positive, down is negative. Right is positive, left is negative. So let's do that. From this to this. So you need to go down first. 1, 2. So that would be -2 because it's down. And then 1 to the right, so +1 here. -2 divided by 1 is -2. So that's our m. There it is then. Y is equal to -2x plus 3. That is our equation. Put it on the line. One other thing that I would advise you to check is the scale of the axes, because sometimes they change that. In here, this is normal. Like one step is actually 1. So 1, 2, 3, 4, 1, 2, 3, 4. So sometimes they might change the scale in here where 2 boxes means just 1. They put 1 here and then 2 boxes and then 2. In which case your counting would change a little bit. So you have to notice that and then adapt to that. Always read properly. Okay, in here, A, B, C, D are points on the circle such that A, B, C, D is a square. So all the sides are equal. And it's 3.5 cm each. Okay. Can't quite see that. Change to red. 3.5 cm and then 3.5 cm in here. Okay. Calculate the circumference of the circle. So circumference is either 2 times pi times r. It's kind of like the perimeter of the circle. How long is it all the way around? You can also do pi times the diameter. From the center to any point on the circumference, that's radius. But if you go all the way through, that's another radius. Both of these, like that whole line right there, that's the diameter. So if you find the diameter, you half it to find radius. If you find radius, you double it to find diameter. And here then, if you're looking for circumference, then you either need the radius or need the diameter. We're going to go B to D all the way. Since the square is in the middle, if we connect this, it is actually going to go through the center. So that's your diameter, BD. Now, how do you find that? We have a square, so it will be a right angle in here. So we now have a right angle triangle. And let's just put BD in here. So in here, you have a Pythagoras theorem question. So again, if you have a right triangle, this is A, this is B, this is C. The formula is A squared plus B squared equals C squared. Now our A is 3.5 squared plus, and then B 3.5 squared. Our C is BD, so BD squared. What is 3.5 squared plus 3.5 squared? It is 24.5, so that is BD squared. But we're not looking for BD squared, we're looking for BD. So the opposite of BD squared will be square root of BD squared. And if you do that, then BD is equal to, what is square root of 24.5? It's around 4.9497. I included a lot of decimals just so that we don't get far from the actual answer. I see in here we want one decimal place at the end. You should never, never only get one decimal place in your middle steps. Never. At the very least, you need to get one more, you need to use one more decimal place than what is necessary for the answer. But my suggestion is you need 2 or more extra, just to be sure. Just to be sure. So BD is that, and that is also the diameter. Diameter. So since we know what the diameter is, this is centimeters, then we can find what the circumference is as well. Circumference is pi times d. So pi times the diameter 4.9497 is going to be, if you round it, around 15.5 cm. So that's the final answer. Put it on the line there. Okay, so that is the final question in this one. I think I'm gonna have enough time to do the other paper. I'll just take a quick break and then get right back to it. Okay, I'm back. That was like probably 1 second in the video. Anyway, so this next paper is November 2021. Okay, let's get right to it. Again, 45%. Percent means out of 100. So 45 out of 100 as a decimal. You can use, and just the calculator, 45 divided by 100. Divided by 100. Do that, 0.45. But I mean, the easiest way to change from percent to decimal would be just boom, boom. 2 steps to the left, 0.45. To go from decimal to percent, you go the other way. 1, 2, there, 45%. When we're writing down factors, the factors of a number are just numbers that go into some other number evenly, no remainders. So what numbers go into 35 evenly, basically? In here, they're only looking for 2 factors. So don't do this, just write down 2 factors, but I just want to explain this to you. This method, I think, is the best for writing all of the factors. You always start with 1, and then you do it pair by pair. 1 times what to get 35 is 1 times 35, and then you go slowly 1 by 1. After 1, it's 2. Does 2 go into 35? It's not even, so 2 doesn't. Does 3 go into 35? There's a technique to find if the number is divisible by 3. You add the digits, so 5 plus 3, 8. Is 8 divisible by 3? No, so 3 doesn't go in. 4, does 4 go in 35? It's not even divisible by 2, so not by 4. And then 5, does 5 go in? Yes, it's 5 times 7. And the nice thing about that method is the last pair that you did, like 5 and 7 here, basically removes so many candidate factors that you need to check. You just need to go in between these. How many other whole numbers are between 5 and 7? Is only 6, and 6 doesn't go into 35, so you know for sure you're done. So just pick, let's say, 5 and 7 here. Now, how would you use a calculator for that? For example, let's say you're checking, oh, does 3 go into 35? You go 35 divided by 3, and then if you get a decimal, then it doesn't go in. Oh, does 4 go into 35? Decimal, no. And then just keep doing that until you find something. But only go in between the last pair that you have found. So no need to go like, oh, there's 34 go in, there's 33 go in. No, just in between here. Next, what is the time 2 hours and 40 minutes after 8:05 a.m.? So we go 8:05. I just add this 2 hours and 40 minutes. 5 minutes there, 40 minutes here. So add 45 minutes. 8 plus 2 is 10. So 10:45 a.m. We need the a.m. because they said here. Or p.m. if it's enough time. Now, I'll teach you like a quick other way. Like, let's say if it goes over, for example. Let's say we start from 8:30, right? 8:30. And then you go add 2 hours and 40 minutes after that. Now that's 70, and then 8 plus 2 is 10. I mean, there's no time that is 10:70, right? But this is just the minutes. So in the 70, you can fit in 60 minutes one time, and then there will be 10 remaining. So this 60 minutes is 1 hour. And then you would put it into the 10, which is our hours in here. So what would happen would be the 10, you add 1 to it, so it'll be 11. And then there'll be 10 remaining, so it'll be 11:10. That's how you would do it for the harder cases of this. Next, 1/6 of 66. Again, if you have something of something, it will be a times question. So it'll be 1/6 times 66. Or you go 66 divided by 6, which is 11, times 1 is 11. So just 11 there. AB is a straight line, mark with a cross X, the midpoint of AB. Midpoint would be the point halfway, exactly halfway between two other points. Now, I don't really have like a nice ruler to use on screen. So this is going to look a bit janky, but you know, you're going to have to excuse me for using this. Anyway, so just make sure you can use inches, but I prefer just using centimeters, millimeters because it's smaller. So just make sure that the first point that you're starting with is lined up with your 0, like that. Okay, but closer, like here. And then just measure. So it looks like here, so that's 0. It's 7.4. So it's 7.4 cm. This whole thing is 7.4 centimeters. Midpoint is what they're asking. So 7.4 divided by 2. What would that be in the calculator? 7.4 divided by 2 is 3.7. So that means that from A or from B, the midpoint would be 3.7 centimeters away. So what you want to do for the ruler is this. Oh my God. Was it always transparent? It wasn't transparent before. What? Anyway, that's nice then. That's weird. Anyway, so you go like that. And then you would mark where the 3.7 is. Now this is going to be a little bit janky in here. 3.7. So 3 and 4 here, right? The halfway point would be 3.5. So you're going to go 2 ticks to the right of that. So 1, 2. So what you want to do is just do a point there. And then after that, remove the ruler and then you do the X right there. Make sure that the point is kind of like in the middle of the X. Okay, that done. That's the midpoint. Next, simplify a times b times 4. So this is all going to be sandwiched inside the same term. So it would be 4ab. If you see 4ab, that means 4 times a times b. Normally, the number we put in front, like the 4. And then if you have multiple variables in the same term, we write them alphabetically, A and then B. Here, what I like doing is circling the terms with the sign in front, just so that I know which is which, and including the sign. So we have two of these. That's 4x minus x, so it'll be 3x. And then this is positive 3 plus 5, so it'll be 8, positive 8. Done. 3x plus 8. Easy, 2 marks. Give away 2 marks. You need to get all of those easy marks. Don't make a mistake. Do not make a mistake in those easy questions. There are 3 cards in bag A and 2 cards in bag B. There's a letter on each card. James takes a card from bag A and then a card from bag B. List all the possible outcomes. So if you get an E from A, then maybe you get a J. If you get an E from A, and then maybe you get K. So we've exhausted all the possible ways that you can get E in the first. So we'll move on to G. So G and then J, G and then K, exhausted, and then F, J, and then F, K. There's an easy way to find out how many total ways you can group them like this. So if there's 3 choices in here, then there's 2 choices in here. If you do 3 times 2, it would give you 6. That means that there's 6 ways that this could go. And it is 1, 2, 3, 4, 5, 6. So that you don't need to do that, but that's just kind of like a quick check that you actually did get the right answer. That it is actually 6. Okay, on Monday, Sandy pays for 2 plane tickets, 7 nights in a hotel, and 2 theme park tickets. Show that. So as a show that question, Sandy pays more than $2,500 on Monday, so we need to prove that. Sandy pays for 2 plane tickets, so this is each plane ticket 600, so we multiply that by 2. 7 nights in a hotel, each night is 120, so times 7. And then 2 theme park tickets, each theme park is 250, so times 2. 600 times 2 is 1,200. 120 times 7 is 840. 250 times 2 is 500. If you add all of them, use your calculator, 2,540. So this is the total in here. So seems like dollars, they're saying. Just do that. So 2,540 is more than $2,500, and that is what they want. Sandy pays more than 2,500, so there. That's basically the final thing that they want you to prove. Done. Next, okay, there's no follow-up there. Vadim has 56 clocks, and they're only red, blue, or black. So in here, the 56, that'll be the total, the grand total, we say. Total here. So we put it there immediately, 56. 32 of the clocks are plastic. So the total plastic would be here. The total non-plastic would be here. Adding both of them, you get 56. So that means that if they say 32 of the clocks are plastic, we put it here. 32 plus what to get 56? We can solve it now. What is 56 minus 32? So it'd be 24. So right there, 24. 5 of the 14 blue clocks are plastic. There's 14 blue clocks. That's the blue, and that'll be the total. So we put the 14 in here, and 5 of those apparently are plastic, so we put it in the plastic row. 5. So how many are the not plastic blue ones? So it'll be 14 minus 5, you get 9. So it'll be 9 here. And then 8 out of the 12 red clocks, so there's 12 red clocks. 8 of the 12 are not plastic, so it'll be 8 here. So that means the red plastic ones would be 12, take away 8, so you get 4. There. So we have exhausted all the information given. We need to do some other stuff in here to find the remaining. 4 plus 5 plus something is 32. So we go 4 plus 5, 9. And then 32 minus 9 is going to be 23. And then 8 plus 9 is 17. Okay, my pen doing something weird again. 8 plus 9 is 17. Then we need to take that away from 24. So we get a 7 there. And then 12 plus 14 is equal to 26. And then 56 minus this 26 is 30. What I like to do is just do a quick check as well. So we did that, and that. So it must be that 23 plus 7 is 30, and it is. So yeah, that's that. You can also check like a few of them, like 4 plus 8, is it 12? 5 plus 9, is it 14? Just a few checks. Okay, that's done. Just complete the two-way table. Easy 3 marks. You guys got this. So easy. Karina has £300 to spend on the books. Each book costs £4.85. Work out the greatest number of books Karina can buy. So every 485 would buy one book. So how many 485s can you fit inside 300 basically is the question. So we divide 300 divided by 4.85. 300s divided by 4.85, or you can also use the fraction key. That is around 61.9 books. Around 61.9 books. But you can't really buy 0.9 of a book, right? So you can only buy 61 whole books. There, 61. Next. Write 196 minutes in hours and minutes. Very easy here. You can go like 60, and then 60 times 2, 120, 60 times 3, 180, 60 times 4, 240. So not this then. You can fit 180 minutes inside there. So 196, it would be 180, which is, this is 1 hour, 2 hours, 3 hours. And then if you do 196 minus 180, you get 16. So there's an extra 16 minutes here. This is 3 hours, and you got a 16 minutes. That's it, done. Another way you can do it, more of a calculator way, would be 196 divided by 60 to find out how many times 60 goes into 196, because 60 minutes is an hour. So you go 196 divided by 60. And it would definitely give you a decimal answer. So it's around 3.26 something something. So there's 3 whole hours. That's what it tells you. 3 whole hours. And 3 hours times 60 to find the minutes. So it'll be 180 minutes. And then you take away the 180 from 196 to find out the extra minutes. Then that's it. It's 3 hours, 16 minutes. Next, a train travels X miles in 2 hours. Write down the expression of X for the average speed of the train. So we're looking for the speed. Again, we're going to use the DST triangle. That looks rough. That's not even a triangle. Anyway, so we're looking for the speed. So we're going to have to use this distance divided by time. Our distance is X miles. And then 2 hours. So it'll be X over 2 miles per hour. And that is what we have in the unit. So you don't need to convert anything. We don't know what X is, but they're just looking for the expression in terms of X, meaning there's X in it. So just X over 2. That's it. Done. Easy. Easy, easy. Okay, the diagram shows 2 places on a map. What is the actual distance in kilometers from Shelton to Trilby? So in here, okay, I forgot that we have this here. See if I can do that again. I don't know. So we have this, right? And then we have this one as well. Okay. So if we measure that, this is going to be not exactly the actual measurement that came up in the paper, because this will be like warped a little bit. But the steps would be the same. So in here, it looks like, so how do I know where to put it, right? I'm putting the 0 right at the middle of the x's, okay, like from Shelton. And then I'm measuring up to the middle of the x on Trilby as well. So right here, you can see that it's this kind of like long-ish line in here. That would be 3.5. And then I think it's one tick down to get to the middle of the x. So sorry, 3.6. 3.6 in here. So that is 3.6 centimeters, but the question was, what is the actual distance in kilometers? So 1 centimeter is 20 km. Now 3.6 centimeters is what in kilometers? So 1 times what to get to 3.6 is times 3.6, of course. So what is 20 times 3.6? Let's do that. 20 times 3.6 equal to 72. So it will be 72 kilometers in real life, the actual distance. So, I mean, again, it will be slightly different from the actual paper, because I think I zoomed in too much, maybe. But again, the steps will be the same. On a scale drawing, so not this scale drawing, the scale is given as 1 to 1,200. How many meters does 5 centimeters represent on this drawing? So when we're given a scale, there's no unit in here, right? Because it could apply to any unit. If you use centimeter for 1, this would also be centimeter, the 1,200. If you use meter for the 1, this would also be meter. So in here, we're looking for 5 centimeters. So we're going to assume that that is centimeters. So 1 centimeters is to 1,200 centimeters in real life. And we want 5 centimeters. So 1 to 5 is times 5. And then that means that you're going to multiply 1,200 by 5 as well. So we 6,000 centimeters. But slowly, careful. How many meters does 5 centimeters represent? So it is 6,000 centimeters, but we need to change it to meters first. 1 meter is 100 centimeters. So every 100 centimeters is 1 meter. So we divide this by 100. Like, you just remove that, or just put it in the calculator. So you get 60. 60 meters. That is the final answer. You put it on the line, 60 meters. Next, in the northern hemisphere, the ratio of the area of land to the water is 2 to 3. So land, water. Work out the percentage of the area of the northern hemisphere that is land. So the total would be 2 plus 3, 5 parts. Now we want to find the percentage that is land. So let's do the fraction first. So land is 2 parts out of the total 5 parts. And you want to find out the percentage. Again, percent is out of 100. So 5 times what to get to 100? You can do like 100 divided by 5 to find out what that is. And it will be times 20. Times 20 in here. So 2 times 20 is 40. 40 out of 100 is 40%. So it'll be 40 in here. You can also use your calculator straight and do 2/5. Hit equals, press SD, it would give you the decimal. And then if you multiply that by 100, which is the same as moving the decimal point 2 times to the right, you would find what it is in percent, which is 40%. Next, 20% of the area of the southern hemisphere. So before we did northern, now southern. 20% is land. Work out the ratio of the area of land to the area of water in the southern hemisphere. So both southern hemisphere. So if 20% is land, then the water, because we're doing percent, there's only two things, land or water, then you'd have to do the whole, which is 100% minus 20%, which is 80%. So that means if there's 20% land in the southern hemisphere, then there's 80% water. So that is it. We can remove the percent symbol. They're both percent anyway. So it's 20 to 80. We just need to simplify that using fraction. So you can change the ratio to fraction form, 20 to 80 or 20 over 80 in this case, just to simplify. So 20 became 1 and 1 became 4. 20 became 1 and 80 became 4. Sorry. So 1 to 4 there. Work out the ratio. So there, 1 to 4. If you're writing fractions or ratios, unless otherwise stated, always simplify. Always simplify the fraction. Except, I suppose, probability questions where normally they would prefer not simplifying. But other than that, no. A stadium costs 600 million pounds. 13/15 of this cost was for the building. The rest was for the land. Work out the cost for the land. So we're looking for the rest. So 1 whole minus 13/15 would give you the fraction that was for the rest, which is for the land. You can just plug that into the calculator. 1 whole in this case would be 15/15 minus 13/15. So when you're adding or subtracting, you just copy the denominator, right? So 15 minus 13 is 2. So that means that 2/15 of the land was, 2/15 of the cost was for the land. Oops. So this is 600 million pounds. So it will be 2/15 times 600. Just take note that it is in millions. So 2/15 times 600. 80. So yeah, 80 million. 80 million. There. Jenna measures all the angles around a point and got 4 angles. Angles around a point will be like something like this. Something like that around a point. So this, let's say, is 23. This, let's say, is 23. This is 69, and this is 145. Now, angles around a point would not angles in a circle. Okay, don't say that. Angles around a point is they need to add up to 360. But do they? Let's see. 23 plus 145 plus 23 plus 69 is actually equal to 260. Explain why these results cannot be true. Angles around. You need to write your sentences properly as well. Don't write it messy like this. I'm just rushing, so that's why. So they should add up to 360, not 260. So I think that's the best way to word it, just to get all of it. Here's a diagram showing triangle ABC, the tiny shaded one, to triangle ADE, which is the big one, like this thing. Describe fully the single transformation that maps triangle ABC onto triangle ADE. So there's translation, which is like moving up, down, left, right. There's reflection, like flipping it over some reflection line. There is rotation, so rotating about a point. And there is enlargement, which is kind of tricky because you can make it smaller as well, depending on your scale factor. But Yeah. So either it makes it bigger or smaller. In this case, it made it bigger. So for enlargement, so describe fully. So you would say what kind of transformation? So it is going to be enlargement. And then you would say what the scale factor is. Like, what do you multiply to get to the other shape? So it's from ABC to ADE. So from small to big. So you're multiplying something. Okay, so I can maybe like just draw it here. So you got ABC, and then you got the other one, which is ADE. So this right here is just 1 right there. And then from A to E, this is 4. So what does that mean? That means that it was multiplied by 4 to get to that, meaning the scale factor is 4. And then there is something called the center of enlargement, which is kind of like a point where like it would start there, the enlargement. So what you want to do is take a point, like say this B, and then take the corresponding point in the other shape, the new shape, and then you would connect it. So you would create a line like that. This C is an E. Do that. So where they intersect would be your center of enlargement. And in this case, it is the point A itself. So we say center at the point 1, comma 1. That's it. So for enlargement, you need to say that it was enlargement, scale factor, and then the center of enlargement. Okay, expand in here, just multiply y times y times 5, so that'll be y squared plus 5y. Factorize 4 and 6, they have 2 as a common factor. There's no a for the other ones, so you cannot pull it out. So 2 times what to get back to 4? It's 2. And there's an a there. 2 times what to get negative 6? Minus 3. So it'll be 2 times 2a minus 3. Now, solving this, you can do 2 times 5x, that will be 10x. And then 2 times negative 4 is negative 8. And then you got 21. We want to find that alone. So since you have a minus 8, we do plus 8. Plus 8. So this goes away. You got 10x equals 29. We divide by 10, so that it's just x. That cancels out. 29 divided by 10 is 2.9. So yeah, x is equal to 2.9 in there. Okay, so in here, we're going to use some laws of indices. For the numbers, just multiply normally. 4 times 5 is 20. And then you have e squared times e. The power for e, if you can't see a power, is 1. If you're multiplying, it's the same base. In this case, yes. You just add the powers. So 2 plus 1, 3. So e cubed. And then you have f times f cubed. So again, if you don't see a power, it's a 1. Multiply same base, f. Just add 1 plus 3, 4. There. Done. Easy. Change 1 meter to square centimeters. So in here, it is not 100. Okay, so just be careful, because the conversion that you might be thinking is this. It is a linear conversion, like just how long something is. But this is area, the centimeter squared and the meter squared. So 1 meter is 100 centimeters. So what you want to do is you're going to square both sides. So 1 squared, meaning 1 times 1 is 1. Meter squared is, well, meter squared. And then in here, 100 squared, what is that? 100 times 100, giving you 4 zeros, and then centimeters squared. Right there. Done. 10,000. You can use a calculator for the 100 times 100. Another way to think about it is because it's 1 square meter, right? So it is a square where each side is 1 meter. So 1 meter here and 1 meter here. But if you want it in centimeters squared, then you can change 1 meter into 100 centimeters. It is true, right? And then this is also 100 centimeters. So to find the area, You go 100 times 100, which would give you 10,000 square centimeters, but centimeters squared. But I like this method more than we need for drawing. This diagram shows two squares. Work out the area shown shaded in the diagram. So these are all squares. So we want to find this area. It's just length times width for rectangles. And since the length and the width for a square is the same, it's just side times side. So if we are able to find one of the sides, let's say that, then we're done. What we can find what the area is. So I think you can see that that's a right angled triangle. So this is 3, this is 5. Then we can find what this is. So it'll be 3 squared plus 5 squared equals x squared. A squared plus b squared equals c squared, the Pythagoras. You got 3 squared, 9, 25 here as x squared. But we don't want x squared, we want x. So we need to do the opposite of squaring, which is square root. 25 plus 9 would be 34. So it'd be square root of 34. I'll just keep it like that. Don't, if you can, don't round anything in the middle steps. So this is going to be square root of 34, and this is going to be square root of 34. So that means that the area of the shaded square will be side times side. So square root of 34 times square root of 34. If that happens, like square root of something times square root of the same thing, you just take it out, like 34. So yeah, that's the answer here. You can put it on the calculator as well if you want to make it sure. Okay, so in here, stem and leaf diagram, this is the thing where you write the first digit or first 2 digits in front. So we start from the smallest. It looks like the teens are the smallest ones. So you got 15, 17, 18, 19, 19. So we need to write it in order. We start with a 1 here. So you go 15, 17, 18, 19, and then 19. So we're done there. Now we do the 20s. You got 20, 25, 22, 25, 22, and 24, and 28. So make sure you mark all these because this is not hard, but one small mistake, then you're not going to get full marks. So the smallest one is 20, of course. That's done. No, 21. I see we have two 22s. So 2, 2. Make sure that you're lining them up. You don't put lines like that, but just make sure you're lining them up. And then you got 24, and then 25, 25, and then 28 right there. Okay, done. And then now the 30s, you got 32, 33, and then 35. That's it. You've done everything. The key, just take the first part. So you go 1, and then do the line thing. And then 5 means 15, or like, yeah, 15 cm. Like that. Okay. The scatter graph shows information about the volume of traffic and the carbon monoxide level at a point on a road each day for 22 days. One point is an outlier. So the general trend of the points is just like going up like that. And this point right there is like so far out compared to the rest. So that will be the outlier. So that's 100 in the X. Always X first. And then 18 in the Y right there. That'll be the outlier. And then for another day, 370 cars pass the point on the road. Estimate the carbon monoxide level for the day. Okay, so we need to look at the scale first. So from 300 to 400, you can see there's 10 boxes in between. And 300 to 400 is 100 away. So 100 divided by 10 is 10. You can use the calculator for this. So that means that each box is 10 for this. And then here, from 8 to 10, for example, that's 2 away. And there's 5 boxes. So it'd be 2 divided by 5 to find out what each box is worth. 2 divided by 5 is 0.4. So each small box in the y-axis is 0.4. So let's see here. Next, we're going to do the line of best fit. So how do you do the line of best fit? You need to use a ruler, but there's a general guide of like going in the halfway, like making sure that it's around like the same number of points on one side and then the other side. So that's kind of like a good trend. 370, so it would be 350 here, 360, 370. So just use that and then go up. So 370 right there, and go up, and then hit the line of best fit, and then you go like that. So again, each box for the y-axis is 0.4. So from 14, you go 14.4. So that's it. When there are 370 cars, the carbon monoxide level is 14.4 milligram per cubic meter. So just there, 14.4. That's the answer. Alfie says because there is an outlier, there is no correlation. So is Alfie correct? No, because we were able to draw a line of best fit. I think that's the most straightforward way to say it. You can say that only that one point is different. And the rest follows it's a positive correlation because it's going up. Sound like that? Okay. Natalie makes potato cakes in a restaurant. She mixes potato, cheese, and onion so that the weight of the potato. Okay. So this is potato, cheese, onion. Natalie needs to make 6,000 grams of potato cake. So that would be the total. 9 plus 2 plus 1 is 12 parts total. Okay. Work out the cost of the cheese. Okay. So we're looking for the cheese. The cheese is 2 parts. 6,000 grams, that's the whole thing. So 6,000 divided by 12. What is that? That is 500 grams. So 500 grams per part. Since the cheese, this right here, is 2 parts. So we go 500 times 2. So 1,000 grams needed cheese. And then what is that? Oh yeah. So for every 175 grams, you need to pay 2.25. So 1,000 divided by 175 is 40 over 7, or around 5.71. Now, assuming that you can like cut cheeses into like smaller bits just to make exactly 1,000 grams, then this is what you do. So you're going to buy this 5.71 times, basically, and 2.25 would be one of them. So 2.25 times 5.71 is equal to around 12.86. That's the answer. Now, assuming that you cannot split it and you need to buy 175 gram cheese blocks, then that means that you need to buy 6. So this is an or another method. So if you need to buy 6 cheese blocks, then you need to pay 6 times 2.25. What is that? 6 times 2.25. Then you need to pay 13.50. So either way, it's all right. As the MAR scheme says that any of them is fine. So write 4.5 times 10 to the 5th as an ordinary number. So if you want, you can just go and type it in the calculator, raised to 5. That's it. So that's 4 zeros after. So 4, 5, 0, 0, 0, 0. or just move the decimal point 5 steps to the right if you want. 0.007, make sure that you're counting the zeros, right? In standard form. So type that in, hit equals, and then change to SD right there. It says 7 times 10 raised to negative 3. And then give your answer in standard form. It's 2 marks. So I think just do 4.2 times 10 cubed. That is 4,200. Plus, you got 5.3 times 10 squared. So you move the decimal point 2 to the right to 530. And then you add them. 4,200 plus 530. 4,730. And then you just change that to standard form. So the decimal point needs to be here. And then 1, 2, 3 to go back to the original. So it needs to be 4.73 times 10 raised to 3. A water tank is empty. Anil needs to fill the tank with 2,400 liters of water. So this is what's required. Company A supplies water at a rate of 8 liters in 1 minute 40 seconds. That's a weird time amount. And 2.2 gallons per minute. 1 gallon is 4.54 liters. So the units of volume is not the same. Company A would take more time to fill. How much more time? Okay. So company A, 8 liters in 1 minute 40 seconds. Okay. Right. So what we can do in here is this. We can change this 1 minute into 60 seconds. Then you add the 40 extra seconds is 100 seconds. So basically it is 8 liters in 100 seconds. Now, since you would do 2,400 liters, how many seconds would that take, right? You would do 2,400 divided by 8, which is 300. So we multiply this by 300, multiply this by 300 as well. So 300 and then there. That's 30,000 seconds. We want it in minutes though. So 300,000 divided by 60, because there's 60 minutes, 60 seconds in a minute. So 5,000 minutes. It would take 5,000 minutes for company A. Now for company B, 2.2 gallons per minute. Let's just convert that first. So we got 1 gallon is 4.54 liters. And we have 2.2 gallons. So this one's easy, just times 2.2 times 2.2. 4.54 times 2.2 is 9.988 liters. So 9.988 liters per minute then. So if we do 2,400 liters, which is what we need, divided by 9.988, we're going to find out the number of minutes it would take. And it is 240.288 minutes. Give your answer correct to the nearest minute. So we'll just, it's the nearest whole minute. I'll just go 240 minutes. We need to find out like how much more time, right? So we go 5,000 minus 240 is 260 minutes. That's the final answer. Write it on the line. This. I'm just rushing a little bit because I need to go actually, but hopefully we can finish this. Fibonacci sequence. A Fibonacci sequence is kind of like this, where normally you would add two previous numbers to get the next one. So like 1 plus 1 is 2, and then 1 plus 2 is 3, 2 plus 3 is 5. Sometimes it's adding the previous 3, but normally it's just adding the previous 2. So let's see if that works. If you do a plus 2a, you get 3a. If you get 2a plus 3a, 2 plus 3, you get 5a. So it works. In here, we know that the sum of the first 5 terms of the sequence is 228. We only have 4 terms, so we need to solve for the fifth one. So 5a plus 3a is 8a. So we know the sum is 228. So if you add all of that, you get 228. And if you do that, you would get 19a. 19a is equal to 228. If we divide by 19, then you would solve for the value of a, which is 12. That's it, done. Put it on there. Right, how many more questions do we have? In a bag, there are only red, blue, green, and pink. Red, blue, green, and pink. Okay. The probability of taking a green counter is 0.2 more. So, okay, so this is like x plus 0.2 then. And then, yeah, this is pink. So what you would do is 0.05 plus 0.15 plus x plus 0.2 plus x. If you add all the probabilities, you would get 1. So if you add all the numbers in here, you get 0.4, and then x plus x is 2x. That's what's going to be on the left. Minus 0.4 minus 0.4, you get 2x is equal to 0.6. Divide by 2, x is equal to 0.3. That means that x plus 0.2, 0.3 plus 0.2 will be 0.5. So that means that the green will be 0.5, and then the pink will be 0.3. There's 18 blue counters in the bag, so we look at that. Work out the total number of counters in the bag. So 0.15 is 15%, or you just go 0.15 of the total is equal to 18. So that means that 0.15 times the total would be giving you 18. So multiplying by 0.5, the opposite of that will be dividing. So we divide by 0.5. The total then must be equal to, 0.15, not 0.5. Oops. Careful, careful. Going too fast. 18 divided by 0.15. Always check your work. Always check your work. Is 120. So the total will be 120 right there. Okay, work out the area of the shaded segment PQR. So just this little bit. So if you have a shaded bit inside a bigger shape and you're trying to find the area of that, the general way to do it is just find the area of the big shape, find the area of the shape that you don't want, which is this, and then take away. That's it. So what you want to do then is find the area of the big shape, which is like the quarter circle. How do I know it's a quarter? Because it's not, that's a right angle. And then we're going to have to take out the area of this triangle in here. So you would find the area of the segment. Okay, so how do you find the area of the quarter circle? So the area of the quarter circle will be basically pi r squared, which is the area of the full circle divided by 4. The radius in here, the OP or OR, is 8. So that means that it will be pi times the radius 8 squared divided by 4. And you would get 16 pi square centimeters. Just keep it like that. Don't round yet. Area of the triangle is base times height divided by 2. The base and the height in here are 8. So 8 times 8 divided by 2 is 32 square centimeters. So using the formula here, the area of the segment would be equal to the area of the quarter circle, which is 16 pi, minus the area of the triangle, which is 32. And you would get around 18.3 square centimeters. They wanted 3 significant figures in here, so that's the answer. If they don't say anything about how many significant figures or decimal places they want you to write, and it's not an exact answer, the decimals just keep on going, then the default answer would be 3 significant figures. Okay. But again, if possible, only round at the very end. Y equals 1 over x, sketch the graph. The graph, it looks like this. Like that. As you can kind of like test it out in the calculator. As you make x bigger and bigger, like 1 divided by 100, 1 divided by 1,000, as you go to the right, the y value becomes smaller and smaller. So it'd be closer and closer to 1. If you go approach 0 from the right side, like let's say, make the x 0.1, make the x 0.001. So you would get bigger and bigger values. And similar for the negative x values. So that's it. I think it would be best if you just memorize that. A few other things. Y equals x squared would look like this, or touches the origin. Y equals x would be like this, kind of like the main diagonal. I think that's y equals x cubed would be like this, steeper, something like that. Okay, I think that's it for now. Thank you for watching. If you have any questions, just leave it in the comments. And if you liked it, please leave a like and share to your classmates to be of help to them as well. Have a good day. I'm Angelo. See ya. Do your best.